Hey guys, this is Mayank Pratap Singh, and I have implemented DeepSeek V3 from scratch. Before jumping into the dataset that I have trained on and the configs, let me show you the surface level code structure and explain the key architecture changes. On the left, you can see the traditional GPT architecture that I have implemented a couple of times. On the right, you can see the DeepSeek architecture with these prominent changes. So the first key architecture change is rotary positional encoding. So traditional LLMs use basic positional encoding, but DeepSeek uses rope because it can handle longer sequences better and maintain relative location information more effectively. So next we have RMS Norm. So the layer norm has been changed to RMS Norm. Basically, the root mean square norm. The key part is that it removes the mean centering step. RMS norms only scales by magnitude, making it much more simpler and faster. Now, let's move to the transformer block changes. So in the traditional LLMs, we were using multi-head attention, in which it splits the attention into multiple heads. It is powerful, but stores full key value pair for every head. So in DeepSeek architecture, we have multi-head latent attention. So basically, instead of storing full KV pairs for each head, MLA compresses them into a shared latent representations. By doing this, we get the power of multi-head attention, but with dramatically reduced memory uses. So the next change was in the feed-forward network. So in the traditional feed-forward, we have a single dense network that processes every token. It is simple but inefficient because all the neurons are activated, regardless of its relevance. So in DeepSeek, we have mixer of experts. Instead of one big network, we have multiple small experts networks. For each token, only 2 to 3 experts out of many get activated. So here is a genius. You can have 8 experts but only use 2 per token. So you get the 4x of the model capacity, but only 25% of the computational cost. Each expert specializes, one for numbers, one for language, or one for code, etc. So multi-token prediction is also one of the key changes in the DeepSeek architecture. In the traditional LLMs, we predict only one token at a time. But in multi-token prediction, it predicts the multiple tokens at the same time. This improves the training efficiency by providing more learning signals per forward pass and enables faster inference through speculative decoding. So these are the major innovations implemented by DeepSeek. In the beginning, I have implemented multi-head latent attention, mixer of experts, and multi-token prediction from scratch on Colab. So after successfully implementing these components, I stitched everything into a single Colab notebook, trained it on TinyStories dataset for 20,000 epochs on A100. It took around 1 hour of training. Again, this was only for the experiment purpose if everything is working fine or not. But there is a problem. Traditional GPT architectures can also handle TinyStories dataset and provide good inference without MOE, MLA or MTP. So I need a more challenging dataset. So I was searching for datasets that is not too much complex for the small language model, but also not too much easy for the traditional architecture. Specifically, I used a FineWeb edu with the CC main 2024 subset. So there are 13 million rows in the total in that subset. I picked only 5 million rows and generated training and validation binary file. Now, let's see the code structure. So most of the core logic is in the models folder. So the implementation of multi-head latent attention is in the attention.py. In the config.py, you can set the configs for training the model. In the layers.py, you can see the implementation of rotary embeddings, RMS norm, and glue activation function implementation. So in the traditional transformers, we were using the glue activation function. But in the DeepSeek, we have used glue. Basically, it is a gated activation function. So the gate mechanism allows the model to control information in the more selective manner. Think of it as having a smart switch and deciding what information passes through, leading to better performance in the LLM. Now let's see the data preprocessing stage. So in the root folder, you can see 2 data prep files. One for FineWeb dataset, another for TinyStories. These load dataset from Hugging Face, filter rows. Also, you can tweak the number of rows to process. So let me demonstrate the training run. First of all, I am going to connect with the cloud GPU by Secure Cell. Here I am using runpod for GPU. Let me clone the repo from the GitHub. After that, I am going to create a virtual environment and installing all the necessary packages. Again, now you have to run the prepare data.py file to generate training and validation binary files. So let me run it. When the running of data prep file is completed, you can see 2 files in the root folder. The first one is train.bin, the second one is validation.bin. For now, I am going to set the epochs to a smaller number for demo purpose. You can change it in trainer.py. And to start the training, you have to run main.py with the flag train. Since I have used for fewer epochs, training completed quickly. Again, you have to train it on large number of epochs. I have trained the model for 60,000 epochs. You can find a trained model on my Hugging Face. So after training, you can see that we have a DeepSeek model. Now to test the model inference, go to run inference.py and update the test prompts list according to your dataset and run that file. Now you can see the output from the DeepSeek model. So this was my implementation of DeepSeek V3 from scratch. The key innovations were MLA for memory saving, MOE for computational speed, and MTP for training performance, making this architecture truly amazing. After this implementation, I can experiment with different kind of datasets, can try different evaluation techniques. At last, we can implement more advancements. So all the code, notebooks, datasets, and resources are available in the post. Refer that. Feel free to bookmark this post or give it a repost to save it into your feed. And thanks for watching.